Okay.
and you can just hide those. Hopefully that works. If it doesn't, let me know and we can talk more about it. All right, it is 6:40 plus, so start calling on some people. I guess again, I'll go in the non-random Zoom order. Actually, it's alphabetized in my participant bar. So how about Alex Song?
Wait, who?
Song, Alex. I'll just be going in alphabetical order, first name, so you know exactly when you're up.
I can't really share because you're sharing your screen.
Right, sorry about that. It's a good point. All right, those are the internal threads, right? Yeah, very nice. There's a couple ways you could do that. I think that's definitely one of them. But keep up the work. Next is Alex Wu.
Oh, okay. Can you see this?
I can see it.
Okay, I'm doing the thing that you were just doing earlier.
Right, that. Yeah, I see the resemblance, certainly. There's
Yeah.
a few more curved things, but I think you got the idea.
Okay.
And I guess what I'll say on that note is that like you don't have to make everything to 100% accuracy if you feel that you don't need to, don't want to. Well, hopefully not don't want to, but if one of the challenges is just too much, you can make a lower fidelity version of it. And you know, the main thing is to get practice in. Getting hours in Onshape will drastically improve how well you can model things in general in any CAD program. So that's the goal here. We're just trying to get practice. Next is Donna. Do you mind sharing your screen? All right. Yeah.
I'm trying to do the texting, but wait, how do you like move it around?
Right now you have it selected, so I'd press the space bar just to deselect that. And you can drag it around by, I guess right now it's fully defined, or it's over constrained. You can see it's red. So it doesn't like that. Somehow, probably implicitly, just by dragging things around, you accidentally added too many constraints. So right now it can't be solved. I would just delete the text and make a new one. Probably the easiest way. That box that you first draw when you use the text tool, that actually sort of constrains the size. So I would keep that within the face that you're trying to draw on. Like maybe even smaller than that. And you'll see how it works once you play around with it a bit. And Onshape doesn't have a whole lot of options for like text size, which is a bit of a shame, but that's how it is.
So if you write like too long of a word, would it like just go out?
It would. I think the text size is determined by how high the box is. So right now it might be too big. In like the up, down direction. Let me look at your axis. In the Y direction, it's a bit long, I think. Yeah, I think something like that, and the word will fit. unfortunate. Well, you can keep playing with that, but you can move it around just by clicking on one of the blue dots maybe and dragging them around. Right, so you can click on the box itself, but not the box, but like one of the blue points. And you want to just select the blue point itself. So right now you have the whole word selected because it's all highlighted. But if you press spacebar to deselect, right, you can just click one of the points and you can drag the whole thing around. And when you let go, the words come back. So
Okay, thank you.
all right, thanks for sharing. Next is Luke. All right, another water bottle. It's a very brief glimpse, but looks good. So you also got the female threads, internal threads. All right, then we have Selena. Ooh, brand name. Okay, looks good. Yeah, for some of these, if you want, you can make an assembly and make things in different part studios. You don't have to, but it does give you more freedom later to move them around, or it's easier to move them around. There's some CAD programs like Fusion, which some of you may have used, where you do a lot more of designing multiple parts in the single part studio, so to say. And in there, you have a lot more freedom to move bodies around and components. But in a program like Onshape or SolidWorks, it's a lot more based on making each part in its own file and then combining them in assemblies. So a bit of varying philosophies. I guess, Thomas, I'm not sure if you're on another computer or something, or if that was you, but if you can, feel free to share.
Yeah, another.
All right, that's fair. If you have any questions, again, feel free.
Eugene, can you share the thing without the black and white thing? Thank you.
Sorry about that. Just
Okay, thank you.
Is there a way to measure the length or something? and
Good
partition?
question. There is. It's a bit discreetly placed in Onshape, but in the bottom right corner, you'll see there's a tape measure and a scale, a balance. So the tape measure is for length. If you click it, it brings up this measure window, and might not be immediately clear how it works, but you can select faces. So I start with a selection of this face, say, and it's kind of smart, kind of like the dimensioning tool. It guesses what you want to know. So I clicked a face, so the only thing it can say about this is the area. Then let's say I pick this opposite face. Onshape observes that they're parallel, so it tells me the parallel distance. It tells me the X, Y, and Z distance between the centers. It tells me the combined areas. You can also do circumferences, or not radii more accurately. Maybe not of that, but if I had a circle, it would tell me the diameter, 2.5, and the radius. And if I want the length of something, I don't have any straight lines, but here I have a straight line. I can measure this line by selecting it. It's a 1/4 inch, and so on. I will show one thing. It's not super important. It's not really in the scope of the class since we're mostly focused on modeling parts, but if you do the water bottle and you're interested in having the assembly where it actually turns like a screw, I'm not sure if you can see that, but you'll see how the cap turns as it goes up and down. So we might not have discussed this before. It's kind of similar to the gear relation, which I think we have. There we go. And it's this one right here. It's called screw. And the way it works is like the gear relation, it doesn't work on parts, it works on other mates. So I'll recreate it for you. It allows you to select a mate, and that's probably going to be a cylindrical, just because that has the correct degrees of freedom where you can move axially and rotate. So here I'll select cylindrical, and I can select a ratio. So in terms of a screw, the ratio is usually going to be, I guess it's not a ratio, but rather distance per revolution. So that's determined by the threads per inch. So when you're making the helix, if the entire length of the screw is like an inch and you have 10 threads, then you're gonna have 10 revolutions per inch. So this you'd put like 0.1 in here. Basically, the smaller the number, the finer the threads. And you'd have to do a little bit of math to find the exact answer, but if you're doing something like this, it's probably just aesthetic. So you'll see now it takes more spins for me to move the cap up and down. Cool thing, if you're interested, not really necessary. All right, so it's almost 7 o'clock, which is the end of the class. At this point, I'd really appreciate if you submitted what you had to Google Classroom. If you really want to finish it before you submit it, that's fine. But it's okay with me if you just submit like an image of what you have and then work on the homework that's due on Tuesday. The main purpose of the assignment for the classwork is just so I have an idea of how hard the challenges actually are, whether or not I should adjust them to make them easier, harder. So without much feedback, I can't really improve. So it's very helpful. And again, that's on Classroom. So other than that, I'll see you next week.